Hello, and welcome to another episode. Just like in a bad B movie, let's try and see the dark side of the moon, or as it's scientifically known, the far side of the moon. Well, let's get into it. To look around the far side of the moon requires us to make use of the strangeness of the moon's tidally locked orbit. This gives us three ways of looking at the far side of the moon. Latitude libration, basically the moon nodding from our perspective, as well as longitude libration, which makes the moon appear to rock. The third type has to do with the Earth's spin, and is called diurnal libration, and lets us look a little further east or west. These effects allow us to see 59% of the moon, not the 50% of the moon that you would assume we would be able to see. The nodding or latitude libration occurs because the moon's orbit is inclined 5.1 degrees to the plane of the Earth's orbit, and its axis is also tilted 1.5 degrees. These effects combine so that every lunar month, or properly called synodic month, the moon ducks below and then above the Earth-Sun line, letting us peer under the South Pole and over the North Pole at an additional plus or minus 6.5 degrees. Rocking or longitude libration is caused by the moon's elliptical orbit. The moon speeds up when it's closer to the Earth and slows down when it's further away. Since its rotation speed remains constant throughout, the two get out of sync. After perigee, where the moon and the Earth are at their closest point, the moon's swift orbital motion outpaces its rotation, exposing a slice of the far side beyond the eastern limb. After apogee, the point in the orbit where the moon and the Earth are furthest away from each other, the moon's orbital motion lags behind its rotation and we see further around the western limb. Diurnal libration is the third method to see the dark side of the moon, as shown in this animation. This effect allows observers on the Earth to see further around the east and west limits of the moon's Earth-facing hemisphere. Basically, this is the observer on the Earth peeking round the moon. This happens because the observer is not at the centre of the Earth, and so at moonrise and moonset, how far you can see along the west and east side of the moon increases respectively. The closer you go to the equator of the Earth, the greater this effect. In fact, at the equator you can see up to an extra 1.02 degrees. This occurs because the movement relative to the moon is even bigger. Before I can show you my examples I've taken of the lunar libration, you need to understand what the north, south, east and west refers to on the moon, because it is different from the perspective of the Earth. As you can see, the Sea of Crisis is roughly in the east, and the crater Tycho is roughly in the south. All the images have been rotated around the Sea of Crisis, to use this as a point of reference to make it easier for you to see the movement. The first example is the greatest northern libration. Here, see in the first image the two craters are right on the edge of the northern limb. Then the great northern libration occurs, and those two craters are now much further down, so you're seeing further along the northern limb. The second example is the greatest western libration. Stevinus craters move towards the horizon, allowing you to see more of the western limb. The third example is the effect of diurnal libration. This image is taken at sunset low down on the sky, which is why it isn't as clear. But look how far over the Sea of Crisis has moved over to the east, allowing you to see more of the eastern limb if the lunar phase was correct. You can find when the next libration is from the Astronomy Almanac on the Astronomic Pioneer blog, link in the description below. I hope you enjoyed that episode. If you've got any questions, please leave them in the comments below. If you like to make any suggestions for new astronomy videos, please do leave it in the comments below as well. We always are interested in new topic ideas. If you like the video, give it a like. It really helps out the channel. And if you'd like to see more astronomy videos, then please do subscribe. Goodbye and clear skies.